we know that a linear equation in two variables, x and y, if you graph it, is a line. But what if we have three variables, like x, y, and z? How do you graph that? Well, if you have three variables, x, y, and z, then you have a three-dimensional system. And we make our coordinate axes like this, where our z-axis is this one. This is our y-axis here. And our x-axis, you can think of it as coming out of the page, or in this case, out of the screen. And so that makes it three-dimensional. So the z and y-axis are on the page, or on the screen, and the x-axis is coming out. Now, if I want to sketch a graph of a plane, well, it's kind of hard to have a plane, and a plane goes on forever. So what we often do is we make the trace. We show what part of the plane we can see that intersects the three axes. So let's take a look at a plane x plus y plus z equals 7. We're going to find the points of intersection on each of the three axes. To do that, you're going to find the x-intercept, the y-intercept, and the z-intercept. Now, it's actually pretty easy to do. What you do to find the x-intercept is you let y and z equal 0. If y and z equal 0, then x equals 7. So we come out on the x-axis, 2, 3, 4, 5, 6, 7, and that's our intercept on the x-axis. To find our y-intercept, we let x and z equal 0, and here y equals 7. 2, 3, 4, 5, 6, 7. And to find the z-intercept, you let x and y equal 0, and so z also equals 7 for this particular linear equation. 1, 2, 3, 4, 5, 6, 7. And then what I do is I draw a triangle connecting the three dots. Oh, that's not a very good triangle. It's not a very good straight line. So imagine that's a triangle, and try to imagine it in three dimensions, and that's the trace of the plane that cuts through. Okay, let's take a look at another one. Let's say that we are looking at 5x plus 4y plus 2z equals 20. And I want to sketch that graph. Alright, so I make my axes. I have my x, my y, and my z-axis. And now I want to find the intercepts. To find the x-intercept, I let y and z equal 0, and that gives me x equals 4. To find my y-intercept, I let x and z equal 0, and that gives me y equals 5. And to find my z-intercept, I let x and y equal 0, and that gives me z equals 20. I mean z equals 10. So I have my three dots, and I connect to the dots to make a triangle. And that is the trace of my plane here, and it shows the line. Each of these is the line where the plane crosses through. Like this is the line where our plane cuts through the xy plane. Here's our zy plane. That's the line where it crosses. And here's our xz plane where it crosses. Okay, well, what do you do if you need to solve a system of linear equations in three variables? Well, that can take a lot of work, and frankly, it's much more nicely done with a calculator, but you do need to learn how to do it on your own. It's very similar to the method that you might use if you were solving two equations. So what we're going to do is we're going to eliminate a variable, and then solve, and then we'll eliminate another variable and solve. So let's say that we have 3x plus 2y plus 4z equals 11, and 2x minus y plus 3z equals 4, and 5x minus 3y plus 5z equals negative 1. Now you actually have several different possibilities for what could happen here. You could find that there's no solution, and that if these were planes, that they didn't intersect at all. You can also find that perhaps they intersect in exactly one point, that there's one point x, y, z where that is a solution to all three of these equations. You also theoretically could find that these planes intersect at a line, and you could find the equation of the line. We're going to look at examples where they intersect in exactly one point, and we're going to find the ordered triple, the x, y, z, that satisfies all of these. So I'm going to start with my equations. I'll number them 1, 2, and 3. And I'll start with equations 1 and 2, and I'm going to eliminate one of the variables from equations 1 and 2. So I'll have 3x plus 2y plus 4z equals 11, and 2x minus y plus 3z equals 4. Looking at these two equations, it looks like it's easiest to eliminate the y if I multiply this bottom equation 3 by 2. If I multiply the bottom equation 3 by 2, then I get the top equation stays the same, 3x plus 2y plus 4z equals 11. And my bottom equation becomes 4x minus 2y plus 6z equals 8. I'll add these two together, and I get 7x plus 10z equals 19. Now, I'm going to take the third equation, and I can combine it with either the second equation or the first equation, but I want to eliminate the same variable. I want to eliminate the y. So looking at the bottom equation, it looks like it'll be easier to use it with the second equation to eliminate the y. So I'll write the second equation. This is equation 2, 2x minus, like that over here, 2x minus y plus 3z equals 4, and 5x minus 3y plus 5z equals 4. To eliminate to eliminate the y, now I want to eliminate the y because that's what I eliminated here, I can multiply this top equation 3 by negative 3. When I do that, this will turn into a positive 3y, and a positive 3y and a negative 3y will give me 0. So when I multiply 3 by negative 3, I get negative 6x plus 3y minus 9z equals negative 12. The bottom equation is 5x minus 3y plus 5z equals 4. Those cancel. I get negative x minus 4z equals negative 8. Okay, now you see I have this equation and this equation. So now I have two equations and two unknowns. So I have 7x plus 10z equals 19. That's from this one. And negative x minus 4z equals negative 8. Now I can eliminate a variable from this one. It looks like the easiest variable to eliminate is the x. I'll multiply this bottom equation by 7, and that gives me 7x plus 10z equals 19 from my top equation. My bottom equation will give me negative 7x minus 28z equals negative 56. I'll add these two together, and I get negative 18z equals I did something wrong somewhere. Let's see. Let's see. Okay, so way back over here, I had a mistake. I had said that I put a 4 here, and it should have been a negative 1. And so when I replace that with a negative 1, this becomes a negative 1. Negative 12 and a negative 1 is a negative 13. I put a negative 13 there. Negative 13 times 7 is negative 91. Negative 91 plus 19 is negative 72, so that gives me z equals to 4. So now I have that z equals 4, and I can plug that into either this equation or this equation to find out what x is. I'll plug it into this one. So I get negative x minus 4 times z, which is 4, equals negative 13. Negative x plus negative 16 equals negative 13. Let's see. So then negative x equals x 16 to both sides equals 3, or x equals negative 3. So now I have that x is negative 3 and z is 4, so I can plug both of those into any one of these equations. I think I'll choose this one just because it looks easiest. So 2x minus y plus 3z equals 4 is my second equation. I'll plug in negative 3 for x. So 2 times negative 3 minus y plus 3, and z is 4, equals 4. Negative 6 minus y plus 12 equals 4. Negative y plus 6 equals 4. Negative y equals negative 2, or y equals 2. So here we have what y is, and so our answer is the ordered triple, negative 3, 2, 4. We do it in the order x, y,